Hello, welcome to my channel. We will be solving this exam. It is mathematics, paper 4 mechanics, and it is uh, May June 2025. Okay, we have already solved six of these questions, so only the last one is left. So let's try to do that one. Okay, so this is the sorry. Uh, Here we go. Okay, so it's interesting question. So the thing is, the scenario is that we have an inclined plane with the alpha is the inclination. There are two masses. One is 6.5 kg and one is mkg. Okay, so uh, the surface is rough, so there's a friction over there, right? Okay, so the thing is we have to find the range of this m, minimum and maximum value of this m, for which this object 6.5 kg, it will stay on the surface. Okay, you see if m is too small, then it will start rolling towards the down, right? And if it is too large, then it will start moving up. So we have to find the range of this m. Okay, okay. First of all, you see we are given that tangent of alpha is 5 by 12. Okay, tangent of alpha is given as 5 by 12. It means we have angle is something like this. So this is alpha, this is 5, and this must be 12. Okay, using Pythagoras theorem, we can see that this hypotenuse is going to be 13. Okay, so from here we can calculate the value of sine of this alpha is going to be 5 by 13, and the cosine of this alpha is going to be 12 by 13. Okay, now this we have to use, we will use these values as calculated in advance. Okay, the coefficient of friction between this object and the surface is 0.4. It's given as 0.4. Okay, imagine this m is so small that it's about to slide down. Okay, okay. One other thing, you see the weight of this object or the mass is acting downward, the mg. Okay, this is acting downwards directly towards the center of the earth. Now, the x component of this force, okay, this is mg and sine theta. I hope you guys know this thing, right? This is the x component. And the y component, which is perpendicular to the surface of inclined surface, that component is mg cos theta. Okay, this much I hope you know already. Okay, now I want to calculate the minimum weight which is required to keep it on the surface, not let it slide down. Okay, okay. So when it is about to slide down, you can see that this upward force. Okay, for this object, sorry, for this object, the tension in this string, tension, this is same as this weight, mg, right? Since there's no motion, so I will assume that the tension is equal to mg. Okay, and for this object, if I draw it again, this is the object with mass 6.5 kg. So there's an upward force which is tension. Okay, whatever the tension in this string, same tension will come over here, and that is the upward pull. Okay, now the downward force is m of 6.5 g and sine of theta, sine of alpha, right? Okay, and since it's trying to slide down, the force of friction is also in this direction, right? And that force, it is going to be mu n. Remember, the force of friction is given by mu n. So in this particular case, it is going to be 0.4, the value of mu. And n, the normal force, is mg. M is again 6.5, and g, and cosine of theta, right? So this is the resistive force. Okay, so since everything is just balanced, barely balanced, so you can see that this T plus this force, which is 0.4, into 6.5 into G. I will use 10 as G. Okay, it's 9.8, but I'm using it going to use a 10. Okay, into cosine of theta, which is 12 by 13. Okay, so this upward force, it is balanced by this downward force. The, so this is the downward force is 6.5 into 10 into sine of theta, and sine of theta is 5 by 12, 5 by 13. Okay, I hope this is clear that this solution of this one, okay, it will give me the value of t, and from this t I will calculate the value of this mass, and that mass is the barely necessary to keep it in place and don't let it slide down. Okay, okay, so let's do this math. So this is t plus, okay, if I calculate all these things, let me do it quickly. It is uh, zero point 0.4 times 6.5 times 10 times 12 divided by 13. So it came out to be 24. And this, I believe it was 25. Let me do it again. So this is 65 times 5 divided by 13. Yes, it is equal to 25. This is equal to 25. Okay, and this tension is equal to mg. So this mg is equal to 25 minus 24. So this is 1. And m in this case is 1 divided by g, and g is 10. So it is 0.1 kg. Okay, so this is the minimum weight, minimum mass of this object, 0.1 kg. If it is less than 0.1 kg, then this object will start sliding down. Okay, easy. Now, we have to find the upper limit, that I keep increasing this mass, right? And after a certain limit, it will start sliding up. So the frictional force is not enough to hold it, right? So now we need to find out that force. Okay, now you can imagine that's the same surface, and this object here, it is 6.5 kg, and the upward force, I'm calling it T, right? Now it is about to slide up. So the frictional force is acting in this direction. And the weight downward is also 6.5 times g, this is 65, into sine of alpha, right? And this frictional force, we know it is 0.4 into 6.5 times 10 is 65, and cos of alpha. Okay, I put theta here, but this technically it is alpha. Okay, so now you can see that this T is equal to sum of these two forces, which is 65 sine of alpha, and sine of alpha, we know it was 5 by 13. 5 by 13, and plus 0.4 into 65 into cosine, it is 12 by 13. Okay, and we did this calculation before. This was 25 and this was 24. So 49 together, and tension was mg as before. Mg is 49, so m is equal to 49 over g, which is 10. So you 49 over 10, so this is going to be 4.9 kg. Okay, so the value of this m has to be between 0.1, yes, and 4.9 kgs. Okay, if this mass is between this range, then the friction will be enough to hold it on the surface. If it is out of this range, then it will either slide down or slide up. Friction will not be able to hold it. Okay, now this B part. Assume that this mass is 12 kg. Okay, so it is more than 4.9. right? So it is sliding up. Okay, so now the scenario is that we have this inclined surface, and then there's an object which is 6.5 kg, and there's a pulley here, and the object is connected through this thing, and this weight or this mass is 12 kg, right? Again, is this angle is alpha. Okay, now the thing is, uh, this object slides down by a distance of zero point 0.6 meter. Okay, so it means this will also move up on the slide on this inclined surface by zero point 0.6 meters, right? Okay, so we have to see using the energy concept. Okay, you have to solve this question using the energy concept. You see, when this mass falls down by zero point 0.6 uh, meter, how much its potential energy will reduce. Okay, so the reduction in this potential energy, it is going to be mgh, we know that, right? Mgh, mass is 12 kg, g is 10, and h is 0 0.6, right? So this would become 72 joules. Okay, so this is the source of energy. The falling down, this is the source of energy. Now, where is this energy going? This energy will is converted in several places. When it comes down, it has some motion, some speed, right? So that is the kinetic energy it has. Okay. Now when this will go up, it has gained some potential energy. That is also coming from this one. And it has some kinetic energy when it reaches up. That's also coming from this energy. And it has some energy has been lost against this friction. So all these this energies, the potential energy of this one, the kinetic energy of this one, the kinetic energy of this object, and the energy lost in the friction, they all sum up to this 72 joules. Okay, I hope it's clear. So assume that when it comes down, its speed was v. So the potential energy, sorry, kinetic energy of this object, which is 12 kg. Okay, this object, it is going to be half m, which is 12, and v square. So this is the velocity which we have to calculate. So you can see this is going to be 6v square. Okay, this is a kinetic energy when it reaches down. Okay, now when this goes up, it has gained some potential energy, right? So the potential energy of this 6.5 kg object, right? Again, this is mgh, but here h is not simple. H is not zero point 0.6 meter as in this case, because in this case, this distance on the slide is zero point 0.6, not the vertical distance. So we need to calculate the vertical distance. This vertical distance is going to be 0 0.6 into sine of alpha, right? So this is the vertical distance in this case. Okay, so mg and h I will use at 0 0.6 into sine of alpha. I hope this is clear. Okay, so m for this object was 6.5 times 10 times 0.6. So let me, yeah, this is points. Okay, this is 10 and then 0 0.6, and sine of alpha was 5 by 13, if I remember it correctly. I think it was 5 by 13. Sine of alpha, 5 by 13 is, sorry. Okay, so this comes out to be, let me calculate it quickly. Uh, it is going to be 65 times zero point 0.6 times 5 over 30. So this is going to be 15 joules. Okay. So the gain in the potential energy of this 6.5 kilogram object is this much. Okay. When it reach up, it has some speed, right? So the kinetic energy Okay, this is the potential energy loss of this 12 kg object. Okay, so the kinetic energy of this 6.5 kg object, it is as before 1 by 2 mv squared. So it is 1 by 2. Mass is 6.5 and it has the same speed as this one. So I will use the same v over here as over this one. Okay, so this is going to be 3.25 v squared. Okay. What else is left? Yes, the friction, the energy lost in the friction. So, or the work done against friction. So let me call energy in the friction. Okay. So that is equal to the force into distance, right? Force into distance. Distance, I know it is 0.6 meter, right? And the force, remember this frictional force, it is equal to mu times the normal force, and we know that this is is zero point 0.4, and this normal force is mg, which is 6.5 into 10 into cosine of theta, right? And cosine of theta was 12 over 13. Okay. Uh, Basically, what I'm doing here, the formula I'm using is D, which is zero point 0.6 into F, which is mu, and mg cos theta. Okay, so this is D, this is mu, this is mg cos of theta. Okay, let me do this calculation quickly as well. It is 0.6 times 0.4 times 6.5 times 10 times 12 and divided by 30. So this comes out to be 14.4. Okay, 14.4 joules. Okay, now we have calculated all the energies. So this energy, which was 72 joules, which was the energy lost by this object, right? So this 72 joules, this is equal to energy gained by this one in the form of potential kinetic energy. So this is 6v squared plus potential energy gained by this object, which is 15 joules plus kinetic energy of this guy, which is 3.25 v squared joules, and plus the energy lost against the friction, so 14.4 joules. Okay, so you can see this is 72 minus 15 and minus 14.4 equals 6 plus 3.2, and this is v squared. Okay, I hope this is all clear. So V is going to be square root 72 minus 15 minus 14.4 divided by 6 plus 3.2. Okay, I hope it makes sense. So when I do this calculation, square root, and here I have 72 minus 15 minus 14.4 and divided by 6 plus 3.2. So it gives me 2.15, 2.15 meter per second. Okay, I hope this question was clear. It was interesting. I hope you enjoyed this one. There are some other alternative ways to do this problem, but I just use the energy method because they're asking us to do this way. Okay, if you ever have any question, you can always ask me in the comment section. Thank you very much for watching. See you in the next video.